All right, welcome back. Today we're going to do an application of quadratic equations. We're going to look at vertical motion problems. What do I mean by vertical motion? Well, if you were to take a ball and toss that to your brother or sister or your friend, the path of the ball looks something like this. Have you ever seen that? Not exactly, but something like that. Looks like part of a parabola. And parabolas, you know, are modeled by quadratics. And in fact, the height of any object at any time t is equal to negative 1/2 a t squared plus v sub naught, that's 0, t, plus s sub naught. Well, this looks pretty hairy, doesn't it? Well, let's break it down. A stands for the gravitational constant. Gravity is constant on the Earth, and that gravitational constant is actually 32 feet per second squared. When you get into high school, if you take physics, they use 9.8 meters per second squared. But in math classes, calculus, I'm not sure why we use this. So this is a constant. When you take half of that, half of 32 is 16. So this first term is always negative 16 t squared, always. V sub naught, remember that sub naught, sub 0, stands for an initial something. That's the initial velocity. So depending on how hard you throw that ball is going to determine how high it is at any time t, right? If you throw it softer, it's not going to reach its max for a while. If you throw it harder, it's going to go faster. So V sub naught times t plus s sub naught stands for the initial height of the thing that you threw. So if you throw this above your head, here's your arm, you're throwing the ball here, maybe that would be at 8 feet. So your s sub naught there would be 8 feet, the initial height of which that thing is launched. All right, so there's 3 things that we can find of any object that's thrown. We can find the maximum height of the object. And if you look at this picture, the maximum height occurs right about here. And you should know what that maximum height occurs at the vertex. And do you remember how to find the vertex? Remember, x is equal to negative b over 2a. This is the equation that you want to use when you're trying to find the maximum height of a thing. We can also find at what time does the object attain its maximum height. So if we were to put this on some sort of scale here, a graph, this is no longer x really, it's time. Time goes on. So this actually is a t here. You could say this is the t coordinate of when the maximum height occurs. But how do we find this coordinate? That's h of t, or y. So this would be the t negative b over 2a when the maximum height occurs. Plug it in to find the maximum height. We're just finding the vertex. Just kind of slightly different wording there. We can also find when will the object hit the ground. Well, let's take a look at that. Someone might catch this ball, but if this ball were continued to hit the ground, what does this look like graphically for you? Isn't this a 0 or a root or a solution? And how do we find solutions? We can factor, or we could use the quadratic formula. And that's why I've waited until now to give you this vertical motion model, because as you can tell, our numbers get kind of nasty, and nasty numbers are most easy solved using the quadratic formula. So class, I just want to stress one more time how important it is that you understand the difference finding the maximum height and finding when the object hits the ground. This is the skill that you'll use in Algebra 2, in physics, in pre-calculus, and calculus. You just have to get these 2 things straight. The maximum height involves the vertex, and hitting the ground involves the solutions. So hit the ground means you want to find out when the height is 0, that's a solution. When is it equal 0? All right, let's go ahead and do a problem. A ball is thrown with an initial velocity of 20, so that's going to be our v sub naught is 20, and leaves the hand at a height of 6, so that would be our s sub naught. So we want to write an equation that models the ball's height at any time t. So we simply fill in the v sub naught and the s sub naught with those given in our problem. Remember, the negative 16t squared is always used because this is a constant of gravity. Here's our v sub naught, 20 feet per second t, plus our s sub naught, our initial height. All right, that's our model. Now we can find the maximum height of the ball. Remember, the maximum height is finding the vertex. So let's go up here and find the vertex. The vertex is found by first finding negative b over 2a. I already did this problem because I flubbed up the first video. Negative b over 2a is negative 20 over negative 32, which is about 0.625 seconds. So what have we found? We found this in our problem, 0.625 seconds is the time when the ball is at its maximum height. Now, how do we find out what that maximum height is? Well, we are going to plug in 0.625 into our equation here. It looks like I don't have enough room, so let's go ahead and do that. So the height at 0.625 will equal, let's plug it in right here, negative 16 times 0.625 squared plus 20 times 0.625 plus 6. I hope that makes sense what I'm doing. We found out the time. Now we're finding h of t by plugging in 0.625 for our t. And thankfully, we have a calculator, so we can go ahead and plug that in. Negative 16 times 0.625 quantity squared. I'm going to plug it in exactly like we have it, plus 20 times 0.625 plus 6. And the maximum height of that ball will be 12.25 feet. So this, if I can write it in here, h of 0.625 is 12.25 feet. It's the maximum height of this ball. Now we want to find, when does the ball hit the ground? When does the ball hit the ground? Well, if you go back to this equation, if something is on the ground, what's its height? Its height is 0. So we have 0 is equal to negative 16t squared plus 20t plus 6. When is the height equal to 0? Now this is why I waited to show you this application, because this equation, this quadratic, is very difficult to solve without the quadratic formula. But with the quadratic formula, we can just plug in the numbers. Here's A, here's B, here's C. Unfortunately, you can't sing it with me. You can sing at home. Let's plug it in. It's not an X, it's a T, but T is equal to negative B plus or minus the square root of b squared minus 4ac all over 2a. All right, let's go to our calculator. So I'm going to do 20 squared minus 4 times negative 16 times 6, and I get 784. I'm going to square root that number, square root the number, and I get, oh, hey, it's a perfect square. That's pretty cool. I just made up this problem. I feel pretty good about that. So this whole quantity here is equal to 28. So we have negative 20 plus or minus 28 all over negative 32. Remember, we need to do this two ways. We need to go negative 20 plus 8. So that would be 8 over negative 32, which is a negative 0.25. Remember, we're looking at time. At what time? So this is one answer. And then we can do negative 20 minus 28, which is negative 48 divided by negative 32. Negative 48 divided by negative 32 gives me 1.5. So t is either equal to negative 2.5 or t is equal to 1.5. All right, let's take a look at that. Can you have a negative time? The answer is no. But why do we get a negative time? Let me show you this problem again. Do you see how the ball left the hand here, went up? It's hitting the ground here, but also if we were to extrapolate, the negative t is back here. Where does the ball hit the ground? This one does not make sense in our the content of this problem, right? So we are not going to evaluate or look at or take that. Do you see how we throw that out? And we do say that the ball will hit the ground in 1.5 seconds. This is at 1.5 seconds the ball hits the ground. So I hope that that was helpful. I'm going to give you some homework problems that are going to take some thought. If you want me to write any out in detail, I would be happy to do that. Please just post them to the stream, or you can also send me a quick email. All right, have fun.